Welcome, everybody, to Stay Curious. I'm your host, Mark Marquette, and this is the most relaxed hour of my day if you're in my shoes. And I'm so privileged to always sit beside this guy who's one of your popular guests here on Stay Curious, Mr. Terry White. Hi, Terry.
Hey,
He's
good
got
afternoon.
he's got gloves on there. You mean business today, buddy. Show your hands up there. He means business today, everybody. Because he's going to talk about the thermal protection system, particularly these blankets above me here that you have right there that shocked me when I saw Atlantis for the first time, my first orbiter up close. I go, what's all these quilts doing all over this thing? I thought there was tiles all over it. So
That's the opinion most guests have. You can't fly a quilt into space at 17,000 plus miles an hour. I said, we can.
but you got some evidence of that. And we're going to talk about one mission that was really an important mission, STS-117 in June 2007, a big hard hat mission completing the big trusses on the space station. And there was an anomaly there that Terry's going to talk about the blankets. So stay tuned, everybody. We got Marty Winkle doing our Streamlabs here today, and he's going to run a quick errand. And you're also going to bring my phone back to me, Marty, when you do that. But how are you, Terry? We love having you here every week.
I'm doing good. So, yep.
Sweater
Glad
weather
to
in
be
Florida
back.
now, huh?
No, not for me. It's just
Right?
it's time to go swimming now that it's cooling down.
Oh, really? Okay. All right. I didn't know. Anyway, it has gotten cooler here. Windows open actually for the first time in months, and
Yes.
Hope that you're all enjoying a beautiful autumn. Got my phone here to talk to you all about questions you might have with Terry. We want to hear them, let me check out here. A couple things there that we get you guys online here starting around there. So we want to thank Terry for being here. He's done it for almost 3 years. There's our slides right there to show you that the job you had, you're involved with, you entered the shuttle era over 30 years ago, or over 44 years ago, quite frankly.
Correct.
But you were there at the beginning
Yes.
in 1978 or 9.
Yep. Yeah.
And you started in the thermal protection system hired, and then he became the manager of the shuttle garage. There was 3 of them called Orbital Processing Facilities. One of the first acronyms I learned around here.
Okay.
The OPF. Okay. And tell us a little about that and looking back in the time machine of those wonderful days of the shuttle.
Well, it was an amazing vehicle. The first time I saw one was in Palmdale, California, Columbia, under construction, and it had a lot of work still to be done, but it came down here Easter weekend in 1979, and it took us 2 years to get the vehicle ready to fly for its very first flight. Now, today we're going to talk about the flexible insulation blanket. That is the quilted material that amazed Mark and amazes a lot of other people that's on the outside of the orbiter. And they call it flexible because you can see it does flex a lot. Prior to that, we had a problem with having tiles that could flex, so we actually cut our tiles into little pieces that you can see here. This is a tile. We glued its pressure.
Hold that up, Terry. They can't
Yeah,
see that.
we glued its SIP strain isolator pad to the back, but then once that was glued, we actually cut the tile right down to the SIP, and we diced it. That way, when it was on the ship, as the structure of the ship flexed, this tile could flex too without breaking.
Didn't know you cut tiles on the ship after it.
Well, we cut them before we put them on the ship,
Oh.
but after they were ready to bond, and that we cut them so that they could flex. They were called diced tiles.
What kind of blade would
A diamond encrusted blade.
Wow,
Yeah,
unlike a handheld saw.
Well, it was on a saw that came down with an arm like that, and you brought it down and run it through a little mill that actually cut the thing exactly.
And
to
show
edge
the
of this.
number on that, please, sir.
Okay,
That everything's identified.
Yeah, this one is, and it's
Up higher,
it's
right.
397. That tells me this one would go on the payload bay door.
Wow, the 3. Okay,
Yep.
so it's like your VIN number. It tells a lot of things, manufacturing, where it was located, that a
Yeah,
VIN
this gives
number
the
on your
whole
vehicle.
history of the tile by that number, but it tells us exactly where it's supposed to go.
Excellent. Before you get rolling there, we just wanted to say hi to Dave Stangy. He's happy to see our Stay Curious family today. Rosalie Jubilee's there. We've got Steve at Lake County Spaceport. He and I will be watching Mexico for our Formula One drivers. And you've got Tom Usiak says, good afternoon and hello, Terry.
Hello.
And Mitch Rothman up in Colorado. We talked about Mitch yesterday, seeing the comet. Greetings from Colorado, he says. Dean Babcock, hello everyone, and nice to see you, Terry, says Dean. And Tom Celentano, always fascinating to hear space shuttle history and from people who made it. That's the only place you're going to get it, Tom, here on Stay Curious. All right, buddy.
Yeah. And this one you can see now. This one's got a part number of 291, and this one tells me that went on the vertical stabilizer. I'd have to go refresh my drawing to tell me where the 291380 went. But yeah, and the ID on these blankets was made with gold ink, real gold. So it was machine sewn in a stitching pattern across there. The biggest blanket.
Gold ink on that right
Yes.
there.
The biggest blankets we installed were 30 inches by 30 inches. So, yeah. And so they were machine sewn with a machine that was manufactured in the early 1900s because the modern sewing machine sewed too fast and it snapped the high temperature thread. So they had to go back and refurbish an old Singer sewing machine to do that stitching.
Gene Wright's been on our show at Sew Sister. I believe they called that lurch.
Yes. Yeah.
Okay.
And when you look at the back of it, there's a lot of hand stitching. All the what we call the closeout stitches, the final stitching and stuff on the back of the blanket is all done by hand. So that's something Gene would do after we fit it and they were ready for it. It would all be sewn by hand. But then just like the tiles, the blankets are installed on the ship using room temperature curing, RTV, and a very thin layer, and it gets bonded to the ship. Now, to bond it to the ship, we had to apply a certain amount of pressure, so we had to build huge fixtures of tooling with a special pad to actually apply that pressure. Hundreds of pounds of pressure for a 30 by 30 blanket to get it to bond on the ship. And so here's an example.
Well, let's go. You want to let's get into that detail here in just a minute.
Go ahead.
We want to set up the shuttle mission that we're going to talk about from June. Also wanted to quickly remind everybody about the auction Saturday. We'll talk all about that tomorrow, wall to wall. And Eric Baker may come in here and share some with us too, as he'll be a docent. But there's 350 lots ready for you to buy up there, and those models are really cool there. Also, some of you, the buzz is there's a cool comet in the night, and I saw it with binoculars last night. Connie McDaniel, you're watching. She photographed it the night before, as did Steve Izzo, a friend of mine. Steve took this picture of Comet Lemon, it's called.
Okay.
This is like about what it looked like in binoculars. Okay.
About what time of night did you see it?
This is 7:30 to, it'll set by about 8:30, okay? About 90 minutes after local sunset. So when it starts to get deep twilight, you look for this, it'll be edging along the horizon. Best thing is just take your binoculars and scan.
Okay.
But to the right is the Big Dipper, and you can see the handle of the Big Dipper. You follow that handle, it'll take you to Arcturus there, or Bootes. But there's no bright star. Arcturus is setting, but it's kind of about 10, 15 degrees above the horizon, depending on where you live. Nice little tail on it. Might be just visible to the naked eye, but with binoculars, or a sea star 6-minute exposure. And I didn't see the tail exactly like that, but I could see the brightness there. So Comet Lemon, go out and get you some starshine. Also, I was looking at some pictures today with Helene Milbert. Hi, Helene. Her dad was Don DePhillips. Don DePhillips was one of the first photographers at Space Center. He took this photo of President Carter on October 1st, 1968, on his 54th birthday, touring Kennedy Space Center with his First Lady Rosalind and his teenage daughter, his daughter was a teenager at the time.
Okay.
And then they went to Disney World. But I wanted to show you this because that is not the wings of an orbiter
Correct.
that I know
I
of.
don't know what vehicle that is.
Looks
so-
kind of like a bow mark on steroids.
Yeah.
But so they found something to prop up as eye candy for President Carter, who's at the presidential podium there. But I just thought it'd be a good picture just to kind of show y'all that we run across pictures all day long. And sometimes we know things about them, sometimes we don't. Like you said, they used Enterprise as the fit check on
Yes.
a lot of things, and
And-
that's definitely not Enterprise.
Nope. In 1979, they brought Enterprise here and lifted it in the VAB, mated it, make sure it go through the structure and all that, took it out to the pad, make sure that everything fit around it at the pad before we actually took Columbia out there 2 years later.
So there is the launch of Atlantis on, get my spectacles here, June 8th, 2007 at 7:30 p.m. So it was still daylight. Nice little twilight launch. Oh, I had a picture I didn't share. You guys had because it was right in twilight, all of the gases from the SRB and the engines made a big trail in the sky that was broken up and was quite beautiful, everybody said. But we're going to talk about the orbital maneuvering system pods.
Correct?
And what's that black thing? What are those black things there?
Those are the high temperature tile. The leading edge of the ohms pods has tile on it, and that is a cluster of black tile, and then around them are white tile. And then when you get just past 2 rows past the black tile, then you start out with the flexible insulation blankets.
There you see it there. And we'll talk about that. And those also have a nickname, those black things. The black areas of the ONs
We
pod.
call that the eyeball mod, because originally they were white tiles there, but one of our engineers discovered that the temperatures were getting too high. The black tile would stand up to 2,300 degrees. The white tile max out at 1,200 degrees. So it was, he discovered that the temperature was getting too high there, and right inside that structure is a fuel tank and an oxidizer tank. So we did a mod where we took off a bunch of the white tile, replaced them with the black tile, and it solved the problem. But when you look at it with the payload bay doors closed, looking down through there, it looks like 2 eyes like you would see on a moth.
Interesting. And modifications. And you want to learn about a lot of modifications. Eric Baker did a great program on that, test project engineer. You knew him well.
Yes.
His baby was Discovery on there. And just so look up Eric Baker, and we have over 1,000 Stay Curious videos up there for you to see. Connie is saying hello, Terry. Connie McDaniel, Doug Forrest. Hello to all from Los Angeles. We've got Robert Law up in Dundee, Scotland. He said he was at the observatory up there last night and saw the comet. And Cliff Watson says, hi, Terry. Cliff is down in Pomona,
Hi.
Australia. Don't know if we told you Cliff has made public that he is battling prostate cancer.
Didn't hear that. So.
And God bless him. He's taken it like a man, but given 3 to 5 years as this progresses. So God bless you, brother, down there. Glad you're here. I know you'll have a good question for Terry. Phil Ramsey says, my 2 favorite rocket men. He needs to get more friends, doesn't he? Thank you, Phil.
It did clarify Rocket Man.
Yeah, thank you, Phil, there. But he thought the outside of the shuttle was covered by a Kevlar-type layer to prevent damage from space debris.
No Kevlar out there. The outside of the orbiter has just got its thermal protection system on it, and then the inside.
That'd be heavy, though, wouldn't it, Kevlar?
Yes, and then the inside of the payload bay has nothing other than the liner material and that to protect it.
And Michael Bruno, hi to you. I believe he's in the Miami area down there. So we want to, talk about a shuttle crew that's not in the month that we're talking about, and that's fine. But we love putting faces to these people, okay? And this is a crew, a pretty experienced crew. Let me see here. I didn't do all my homework with today. This is Fred Stutkow is the commander, and he's there on the right. Okay, this is his third or fourth flight. He is a Virgin Galactic pilot and been
Okay.
suborbital 3 or 4 times. Lee Archibald, it's his first flight. I think he did 3 on the left there. Pat Forrester, second flight. Steve Swanson, first flight. John Olivas, first flight. James O'Reilly, third and last flight. O'Reilly's in the middle there with the mustache. And they took up Clayton Anderson and brought back Sonny Williams, okay, on that flight. And Olivas is on the far right there. So he did the spacewalk that we're going to talk about today. Danny Olivas on the far right, Hispanic American astronaut. And as you all know, I love the patches. Indulge me while I share with you the artwork that this patch symbolizes the continued construction of the International Space Station and our ongoing human presence in space. All right, the yellow is used to highlight the portion of the International Space Station that will be installed by the crew. So this is truly the last big segment to be added in 2007. You see that on the left. It consists of the second and third starboard truss sections and the third set of solar arrays. The 2 gold astronaut office symbols on the bottom emanate from the 117, represent the concerted efforts of the Space Shuttle and International Space Station programs towards completion of the ISS. The orbiter and unfurled banner of red, white, and blue represent our nation's renewed patriotism as we continue to explore the universe. So, beautiful patch, always catches my eye when I see it. And now you know some of the artwork behind that. But before they could get launched, this is they had damage to the external tank, and it wasn't woodpeckers.
It was hail this time.
Hail it was.
Yes.
Hail, atmospheric hail
Yes.
coming from the sky.
Yes.
All right. Pretty big hail, though.
Yes.
Certainly you've had hail hit orbiters before. Is this the first time this happened?
No.
No?
Hail hit 102 years ago, Columbia, and it actually, in the long run, it helped us. But we went out it was at the pad. We went out to the pad and reached all of the damages we could reach to harden the material because NASA opted not to bring it back and destack it and that. So using paintbrushes on the end of broom handles to reach all the way out to get as many things as we could and harden it. Most of the damage was all up in the forward, and it flew. And when it came back, they thought the damages would erode and have big holes, and they did not erode. So basically it changed our criteria and allowed us to to not repair a lot of things.
Damage was to the tile, though.
To the tile, yeah. So we still had to harden the material, but we didn't have to go, fill it with a putty material.
Well, here's the technicians at the pad, I assume.
Yes, yeah.
At what, 250 feet up?
Actually, that looks like in the background, looks like they rolled back into the VAB, and I don't recall whether they went back into the VAB to do the repair, but yeah, that's floor structures in the VAB because there's not that much structure at the pad.
Yeah,
around the top of the tank.
There's the
Yep.
repair of it.
Yeah, that would be in the VAB.
Hail damage on February 26th previously caused the launch to be postponed, so they did pull it back. STS-117 marked the 250th orbital human space flight. It was also the heaviest flight of a space shuttle because of the trusses that they took up. The second set of starboard truss there. And so let's get, Marty, you had a question. Marty had a question before I get to rolling here with Terry.
Yeah, we had a comment from Michael Bruno. The orbiter model with Carter was called a Pathfinder, and it would be used to validate ground installations before the arrival of Enterprise in 1979.
Okay.
Thank you.
I never saw Pathfinder.
Me
But, yeah,
Path-
I've heard of it. Yeah.
wasn't Pathfinder out at the shuttle runway for a while?
It could have been, but yeah,
No. Pathfinder, I think, ended up at Huntsville
that's probably where
on
it's
top
at.
of the ET up there,
Okay.
and they fixed the. But you all correct me on that, because I can't know everything. Thank you, Michael Bruno. That's what we wanted to know. That makes sense. And Lynn Feather, hey Lynn, great to have you on board here today. She says hi, Terry, Mark, and Marty. All right, so great to. All right, let's kick off what you want to talk about, the OM's pods, and there is what's that one doing there?
Okay, that is an ohms pod that's in its ground support fixture. It is currently off of the ship. So the ohms pods and the forward reactionary control system, the things that maneuver the orbiter when it's in space, they are designed to come off of the ship and go to the hypergol maintenance facility to do heavy maintenance on them, because they have the most hazardous commodities of the orbiter are inside those, the monomethylhydrazine and the nitrogen tetroxide. So yeah, we have to physically put special fixtures on them and lift them off of the ship and take them down to another building.
All right, ship being spaceship. And there we have a situation that we see many times, the OM's pods. That is the only major maneuvering fuel system on board. How many RCS thrusters are
There's
there?
16 on the forward, and then a total of 32 on the ohms pods, on the two pods. Now, and you can see there some of the white tile look nice and bright white, and some of the others look dingy, gray, and dirty. Thermally, they still do their job, so we just did not replace them because they didn't look pretty. That's why they kept me around. I didn't have to look pretty to still work.
Okay, that's good. Indeed. And when you see a dark black tile, these exceptions here on the belly of the shuttle, those are the newest ones.
Yeah, the pristine black, but the upper surface doesn't get that gray coloring because they don't see the extreme temperature that the lower surface tiles do. So most of those stay black through their entire program.
So that's the same type of tile
Exactly.
that we see on the belly of Atlantis, that
Yes.
all of them are gray,
Yeah.
and some of them are the newer ones. Okay.
Yep.
Very, very cool. All right. Well, here's what happened. Tell us
Okay, this is not the first time it happened, but over the forward reactionary control system thrusters, to keep rainwater out of them, we put Tyvek covers on them that had a system designed to pull them off. Once they left the launch pad and got a little ways up, these were supposed to pull off. Well, in this case, it didn't pull off until it got further up, I guess, but they suspect that's what caused this damage. And what it did was it hit one of the blankets just after the tile and rolled the edge of the blanket up, exposing the structure underneath. So, and I have an example here of a blanket that's installed on a panel, but it basically rolled it up like you see I'm rolling this up right here, and then you can see the aluminum underneath exposed. So they didn't want that to return back through the atmosphere.
see that again. There's here's some of the other. This was not a one-time thing. They'd seen it since 1982. It looks like, with 41B, 41C. Or STS-1 had some even.
Well,
so.
yeah, but they didn't have the blankets. They had the white tile back there, and we actually lost on STS-1 some tile or pieces of the dice tile back there. So yeah. So this is the first time I knew that the second time that the blanket sustained a peeling effect. The first time was on return to flight, STS-114, and that was by window one of the blankets peeled back again, caused by the Tyvek cover coming off the forward reactionary control system.
Show that again, that peel back that you were showing, because this relates to that.
Yes. Yep.
Yeah, high up there. See, you see what this image is showing you. So. Right there's the ship.
Yep. This blanket happens to be installed on what we call a carrier panel. This is a very thin aluminum panel, but we have to access something underneath it. So we glue the blanket onto the panel, and then we can unbolt the panel. And right here is all the stitching that's associated with the hole that we have to put the fastener in to bolt this panel onto the ship.
All right. So we had this tear.
Yep.
On here,
yeah.
And that we shown there. This was the longest shuttle mission at almost 14. For this orbiter, not the longest total, but it was the longest for Atlantis.
Well, they delayed 2 days
yeah.
to go do this repair.
13 days, 20 hours.
Yeah.
It was, when I said it was also the heaviest, well, I'm thinking about 42,000 pounds
Yep.
is what it took up. And a lot of that was the orbiter docking system, the truss segments. The truss segment itself was 35,000 pounds. That was most of it there. So she was heavy. All right.
So just like in Apollo 13, when they went and looked at all the different components that the astronauts had on the vehicle that they could use to solve their problem, we did the same thing with the orbiter. So the ground support down here was looking into how do we fix that problem up there? What materials do they have available to work on the fix? So I happen to have some of the previously flown blankets from other missions that I could give to them so they could put them down and test what it would take to work on a previously flown blanket. But basically what the crew did when they decided, okay, we're going to go do a spacewalk to repair this, because the first time it happened on 114, they opted not to go repair it because of where it was on the forward. But here on the OMS pod, they wanted to go repair it. So they planned for a spacewalk, and the crew used a blunt needle to sew the blanket
Show that.
to the adjacent material, and he's got a photograph of it. Yeah. So, well, that's a tool they use to put the spikes in later. But a needle that they had on board for sewing up some of their space suits to change the sizes of make the suit fit better than that. But so they used that needle to go sew it back together. There was some of those to the adjacent blanket, and then they took the stapler out of their medical kit and used it to staple the blanket material together.
That's what that is.
Yep. And then they used and that was
a medical kit.
It's out of the medical kit. It's called the multi-shot disposable skin stapler. All right.
All right.
Okay. Then they had some push pins that they used, and they poked them through this corner that was sticking up after they'd pushed it back down. They wanted to make sure it stayed down into the adjacent tile. So they actually jammed these spikes through the blanket right into the tile to hold that on. And they using tools that came from their dental kit. So they went to their medical kit, their dental kit, and took the tools out of there to go fix the blanket.
And this is Heidi Piper checking this out in a look at those gloves, Marty. I was saying, I know this wasn't in space, because look at those gloves. And I don't think she was in the water to do this.
No,
just
so,
probably.
Yeah, so they had to test everything here on Earth just to make sure that those things would work as they envisioned them to work, and do it here on Earth before they had an astronaut on a spacewalk attempt it. Especially if he's using sharp tools.
So here was Olivas went out there on the robotic arm. There you see him on the lower right going out there, upper left, and as you see the back of his head there. On the OM's pod to the right is another of him doing it. A couple more random pictures. Thank you, Collect Space, for posting these. That's where I harvested these to kind of give you an idea of everything's being watched, particularly the lower right-hand corner.
Yes.
There you see what he's doing there.
Cameras in the payload bay and cameras on the robotic arm are filming everything that's going on, so that the rest of the crew can see it, and everybody here on the ground that needs to see it is watching as well.
I don't know how long that took time-wise. I didn't look it up.
Yeah, I didn't see it list how many hours it took, but yeah.
But nothing trite about going out in space and then doing a repair. What was the danger level of this?
Anytime you're doing a spacewalk, to my knowledge, is extremely dangerous.
I the re-entry of Atlantis. What was the
how
fear of this re-entry?
Well, the fear would be that corner sticking up, catching the airflow would peel it back even more and expose that structure underneath, which is not to see more than 350 degrees. Is not what it's not designed to. That blanket protects it.
Okay.
So, you know,
So they're saying 350 degrees about that blanket.
yeah,
Think
so
of your oven making a cake.
yeah, yeah. So you don't want it to get any higher than that. So they had to get that blanket pushed back down, and just pushing it down, it would stay and still it till it started hitting that extremely high airflow, and then it would peel it up and possibly peel the whole blanket off, not just the corner.
And there's, of course, that nasty fuel in that tank there that
Yes.
would make a
Yeah.
big explosion.
Correct.
Marty's got a question for Terry White. Hope you're enjoying as much as I am, our guest today. Go ahead, Marty.
Yeah, we have two questions. First one is from Rich Rothman. Are the samples Terry is showing part of the museum's collection? Are they his own?
They're the ones I carry around that,
Not yet.
that are loaned to me from when I used to brief people out at the Space Center. So I still use them for
Hold 'em
briefings
up
I do
there, yeah.
nowadays. I mean, you know, I have tile, I have blankets, and I have frizzy that I carry around and show different people because it's hard for them to understand, especially when you talk about
There's my
a quilt.
frizzy.
A quilt on the outside. Yeah, he's got multi-layer frizzy, and I've got a piece of frizzy here that we call a ramp because it's multi-layer at the back, but it goes down to a single layer at this side. And what it would be done is it would be used to ramp up to something like this. But this is for areas that see less than 700 degrees, and this is for areas that see less than 1200 degrees.
Yeah. Works as a great coaster here in our Stay Curious studios.
Okay, the second question is from Dean Babcock. What is the raised section of the tiles behind Mark on the green screen?
What is the temperature ranges?
No. What is the raised section? What I think maybe he's talking about, Mark, if you move your head one way, I think it's just the Ohm's engine
Oh, behind,
nozzle.
okay, that goes back, and then the raised section behind there, the black section is actually the nozzle of the orbiter maneuvering engine.
Off your shoulder, okay.
Yeah, off of your shoulder. That's what he's asking about. What's that behind
Oh,
you?
yeah.
Okay, and then the other thing below the black, you can see 4 round circles there and a smaller round circle. Those are the thrusters that are back there. So those use the fuel inside the tank to actually fire and maneuver the orbiter. But the one up above is the orbiter maneuvering engine. Once they get to space, they use that to achieve a higher orbit. And also, that's the real critical one, that's the one that brings you home. So when it comes time to come home, they fire those to slow the orbiter down from 17,500 miles an hour to 17,300 miles an hour. And then mom gravity takes over and starts bringing the orbiter down.
Mm-hmm. And these are also the maneuvering units to go rendezvous. And,
Yeah, like you're going out to Hubble, you have to fire
Yeah.
to go further out, and that's, yes.
Okay, all right. Great question. Thank you all. Let's see here. Yeah, we're kind
Yeah,
of
and this is not
at the end here.
This is
of
only the second time an astronaut went out on a spacewalk to repair part of the thermal protection system. The first time was astronaut Steve Robinson went out on STS-114, returned to flight, and that was 103, and he went out underneath because the cameras detected there were 2 gap fillers that were protruding on the lower forward. So he went out on a spacewalk, and we told him all he needed to do was, he had a bunch of special tools. We told him all you have to do is get a hold of them. If they're protruding, they're not properly glued, they'll pull right out. And he told me after the fact, he said, you were right. I just got a hold of them with my gloved hand and pulled them right out. So,
and then what happened to that protruded piece?
Well-
Where'd you see that again?
at the runway, Steve handed them to me and says, here's your gap fillers back.
That's cool.
And I had them at my desk for quite a while, and then NASA realized who had them, so they came and took them. Supposedly they're in the Smithsonian. I didn't see them when I was at the Smithsonian, but yeah, so.
Yeah, and that was Steve Smith?
Steve Robinson.
Oh, Robinson, Steve
Yeah.
Robinson. Yeah.
And then
I've
later,
not met Steve
yeah,
Robinson.
later
I've met
on,
Steve
since
Smith.
he didn't have them either, we made him a certificate, because basically you have to be certified to remove the gap fillers, but we made him a special certificate, mounted in a plaque in that with a couple of gap fillers to thank him for removing the gap fillers.
All right, Marty's got another question for you, Terry.
We have two questions. The first one's from Gary Gerald. Terry, how are the OMS pods connected to the orbiter?
Okay, the OMS pods sit at the base of the vertical, and they are mechanically fastened. Basically, they are bolted to the orbiter. And then all of the electrical and then the fuel lines and everything else is connected. They rest at the base of the vertical. You can see some photos somewhere of you'll see it looks green back there or gold with the blankets and that when they lift them off. But basically, it's a flat deck. The pods are, you know, all
So it's a
contained.
flat surface that it's on, and
Yeah.
well, you know, that'd be a good show to dissect, just take it apart like
Yeah.
one of those.
Yeah, and there's some good pictures of
pull
that.
apart.
the FRCS
Well, you
coming
got the model over there,
Yeah, but these don't come off, so it's really hard to show you.
but you can see the.
Yeah, you can see the orbit maneuvering pod, and you can see the one here, and you can actually see the fuel tank and everything. And you can see on this view, you can see more thrusters around here, and then the orbiter maneuvering engines.
That deck that comes off cleanly there, and underneath there,
Yeah.
it's just a sort.
Yeah,
So
it's
did
just
they
a-
bolt it from inside, like you would the nut
Both.
inside the fuselage
yes.
and the bolt on the
Inside the
outside?
aft compartment, yes.
Boy, that's a tight fit, I'll bet, for a
And the
technician
forward
being there.
reactionary control system is the 16 thrusters up front that comes off. And the same thing, they put it back on and it's bolted back in place and that. And then panels, and these panels around it have all tile on them, but they go around it to close out that area and seal it.
Okay. Using Discovery 103 there to show off there. Marty's got another one for you, Terry.
Yeah, we have several questions. Next one is from Mostly Park. Was there ever a flight no tiles were damaged?
No.
Okay.
Wait, they got better and better as the flights went along, but we still sustained damage. We sustained damage from micrometeorites. We sustained damage from space debris. We sustained damage from insects, bird strikes, all kinds of things damage the tile, even on ascent or returning.
Okay, next question is from Michael Bruno. Do you know if the Buren used thermal blankets also?
To my knowledge, they never used thermal blankets. I never saw any evidence of it, and they only flew once, and they didn't have their tile configured correctly. And I understand they severely overtemp the orbiter. That's why they never flew it again.
Okay, next question is from Gary W48. Have there been any spin-off usage for shuttle tiles, and if so, where? Can the materials be used for home installation purposes?
Well, it could be used for home insulation, but you better have a very large pocketbook because tiles are extremely expensive, but they are used on all of the current other space vehicles. You know, SpaceX uses them. Blue Origin is going to use them. And, you know, what's the little one that looks like a little mini shuttle? It's built in Colorado.
X-37B.
Yeah, well, yeah, X-37B uses them. So
Oh,
a lot of others
Sierra.
use the
A
Sierra
Dream Chaser.
Nevada Dream Chaser. Yeah, and Boeing capsule uses them. So yeah, the capsules, the main surface that sees the most heat has an ablative material just like Apollo did, but they do use tiles and blankets on their other surfaces.
Clarification, I've read here that Dean Babcock and Steve Jokim's going back and forth. Dean is asking about this big square here. See how this goes up here? Wait, where my finger's going? This area right there, Terry. This one big tile.
Oh, that's not
And
a
they
big
look
tile.
like there's fasteners on it there.
There's blankets, but you'll see fasteners. That's a lower temperature area. So up there, you can see around some of the fastener holes because we don't put anything in the holes. That's a low enough temperature that the insulation around those things protect the structure underneath. So we
So
don't
they're
have
between us there.
we don't
Between
have to put a plug
Yeah.
in between it.
There you go.
Yeah. So yeah, that's all just, and parts of the orbiter maneuvering system are covered with the frizzy.
Mm-hmm.
So you don't have anything in that, but most of that is all covered with the flexible insulation blanket.
Okay, next question is from Mostly Parked. Is that model up for auction? That's the one you held up.
Oh, actually, that's a popular model you can buy for about $120. It was a very popular kit. I don't know who put it together, but I've seen them available out there in the eBay world. So, but yeah, it's the fact that you can see things in it is awesome. But it's probably one of those series with the engine that you see and stuff like that
And,
going on there.
and to clarify more on the question about does the TPS have any use outside of the space program, Mark knows about that. We actually installed blankets on NASCARs.
Yes, there
They
you
actually
go.
brought them here to the Space Center, the first one, after giving a tour to a bunch of the NASCAR drivers and crew chiefs and that, and explained what temperatures these things. They got interested in it, and they brought one down here, and they actually installed the blankets on the inside of the driver's compartment and that to cut down on the heat from the engine and the track and that.
Yep.
So,
Jay
yeah.
Honeycutt
Yep.
was in on that. You
Yep.
you knew that. He
Yep.
he actually rode an elevator with Bobby Allison, the great driver,
Yeah.
and they struck up a conversation about it's awful hot in there. Is there something in the shuttle that keeps heat out that we could use? And
I
it's very
showed that to
important.
Earnhart and Elliott one night when they were here on a Sunday night after the races. So
Did
yeah,
ya?
yeah, Earnhardt Senior. So
Yep. So we'll have to talk about that one day because we've talked about many times. I covered NASCAR as a photographer up in Appalachia, mostly Bristol. Okay, Marty, another question.
Another
Great
question.
show today, everybody. Thank you for your interest.
From Sherilyn 2C6671, what kind of ceramic fiber?
okay, it's actually made from silica, from sand. The tiles are made from sand. They're basically air. The blankets are made from sand. It's a high purity silica, 99.8% amorous silica. It's a non-crystalline formula of silicon dioxide. And the silicon fabric, the material on the outside, is with the batting sewn in between. And we use, like I said earlier, the high temperature thread, which will stand a lot of higher temperature than that, but it's extremely brittle. So when you sew it, you have to be careful that you don't snap it. So
We're having fun today. Mostly Park made a comment that the thermal protection system could also keep Junior Johnson's moonshine cool
it
in
would,
the back of that trunk there.
because it protected the orbiter from the high temperatures of reentry, but it also protected in space, because in space, so you're faced away from the sun, you're a negative 250 degrees Fahrenheit. You face toward the sun, you're a positive 250 degrees. So, well, one thing about it, the vehicle TPS in all of its systems, all the tile, the RCC, the blankets, everything, adds 8,500 pounds to the orbiter, and 20% of that is the reinforced carbon, while the reinforced carbon only covers 2% of the vehicle.
8,500 pounds, so that's a little more than 4 tons
Yeah.
of a 200-ton spaceship.
100-ton spaceship.
Okay, 100
Yeah.
ton. All
Yeah.
right, 100-ton spaceship.
Yeah.
I was thinking 200,000 pounds.
Yeah.
So less than 4 tons
Yeah.
of a 100-ton spaceship is protecting it. That's
From
the
nose
ratio I
to
never thought
tail,
about.
top to bottom. Yep.
worth the weight in gold, I would say.
Yes.
Yeah, go ahead, Marty. We're having fun today. His arms are waving up there. Go ahead.
Okay, two more questions. One's from RG Jubilee. On the crack tiles that you showed in the beginning, when you put the pads underneath,
Yes.
how does the heat not penetrate between the cracks?
Okay. It does, but that pad
Hold that
that,
up
that
there
pad
between-
underneath you see is red there. That's the adhesive on it, but that is the Nomex felt, and that will withstand up to 700 degrees. Now, heat coming down through those cracks, the tile absorbs that heat. So not much gets down to the pad, but the pad will withstand up to 700 degrees. So
Show
this
that
is
flat for
this
people.
is in areas that should see less than 1200 degrees on the top. So it's not going to get to 700 degrees down the side.
Good question there. Everybody's fun watching there. Go ahead, Marty.
Okay, next question is from Robert Law. Was Challenger the first orbiter with thermal blankets?
Yes, you must have looked at it at the visitor center, because they have a piece of Challenger's sidewall in there. But when they came out with this, the Ames laboratory came out with the blankets and that, and Columbia and Challenger were built without blankets. They had white tile. So at any rate, when they came out with these, they wanted to test them. So we took 4 locations on Challenger, and we took the tiles off and we put the blankets on in their place. These were relatively low temperature, down the mid sidewall, on top of the crew module and that, and flew it. And when it came back, the sad part was that the airflow actually tore the blankets apart. Now, all the stitching that you can see there, see all those stitch lines, they were still in place. But what it did was it tore the fabric and all the batting came out. But the bottom of the blanket was still glued to the ship, so that helped protect it. And that it didn't overtemp anything, but it told us that we had to do something to stiffen the outside of the blanket to allow the airflow to go across it without tearing it. So we came up with a process called, I say we, but that was Ames Laboratory, came up with a thing called C9 coating, and it was a special coating that we put in a 2-stage process in that, and we calculated how much we needed to put on there based on the size of the blanket. But the technician actually painted the pre-coat and then the top coat on it, and then it stiffened it just like you would glaze something that you wanted to withstand, touching in that without tearing. So yeah, and it still allowed it to flex.
All right. And when we say airflow, we're talking hitting the atmosphere, going through re-entry plasma. It'd be going at what speed? 4,000 miles an hour?
No, 17,300 when it starts in. As it goes down through the atmosphere, then it's slowing all the way down to a little less than 200 miles an hour.
Right, but when it comes out,
when it's coming in, it's slowly getting down from that. And then actually the orbiter does this type of maneuver coming in. It doesn't come in like this. It would get way too hot. So it comes in with an angle, but it goes back and forth like that, dissipating all that heat and speed.
Oh, I didn't know that.
Yes.
It swings back and forth.
Yes.
Huh? Okay.
Yeah, and it's at that time it's all controlled by the computers. It's coming in. So when it's a lot lower down is when the commander actually takes over and flies it.
What a ride. What a ride. What a ride. So, yes, loving everybody's questions today. Marty, any more on our UCX family microphone there?
No, we're caught up for now.
Wanted to mention Chris Callie's watching. Thank you, Chris. Our partner with Shuttle Fest and a great artist. Doug Forrest, of course, is a good artist. He's out there in Los Angeles working in the Hollywood CGI world.
I want to thank my wife for watching, and Lynn. And Lynn, you can still send me your cold temperatures. She said West Virginia's getting cold already.
Oh, is she?
Yeah.
West Virginia?
Yes.
Yeah. Oh, of course. Yeah. That's why they're up there. They love to wear plaid and wear those warm, fancy coats and stuff. Yeah, Marty.
Hey, Michael Bruno's asking, were the windows made of some kind of heat-resistant silica?
Yeah, they were made by Corning, but it is a heat-resistant glass. But it does withstand. But that was the weakest portion of the outside of the orbiter was the windows, and it is a triple pane system. So yeah,
the weakest.
Yes, they are. Yeah, and I didn't find that out until I suspected it, but until after the Columbia incident, they confirmed that it was the weakest.
Well, again, we might just do a show on those windows there and talk about what they're made of. Many of you didn't know they were triple pane, which is of course very interesting. And the piece of Challenger you alluded to is, of course, in the beautiful memorial at the Kennedy Space Center. Forever remembered out there. My friend Mike Chinelli had a hand in putting that together. You know Mike, I believe.
And we'll show you a picture of that. I didn't take one before today's show, but Marty or I on our travel through there, we'll take a picture of it.
Very
and
stunning.
show you.
On one side is the side of the shuttle. You're familiar with it, with the American flag on it. And you've seen it on a crane that they brought it up when they brought it on board the ship. And then they have the windscreen of Columbia on the other side there.
Yeah, the whole window frame from the 6 primary windows. Yeah.
And when I first saw it for the first time, I go, my God, they left the pine needles in it, in the mud, just like it was. And that's so dramatic in there. Well, let's get 117 back down the ground. Here's the crew with Sonny Williams exchanging some gifts between the Russians and the Americans there. That's what the finished space station looked like. It didn't have the left side, that the solar panels or the mechanism to put that on there. A huge mission in 2007 as they floated away. That was their work there on the left. Wasn't there when they approached it. How cool is that to really see that you're doing something there? And there's the crew in their Hollywood poster that they made. up there, and then I thought it'd be appropriate, since we're talking about the OM's pods, to show one of my very favorite shuttle era photos.
Okay, that's a good one.
The air glow of a shuttle. Actually, this is not during reentry. I believe this is actually going through the Aurora Borealis.
All right.
But an early shuttle took this one. Can't remember. Somebody will and let us know there as we finally get Atlantis down on the Earth, landing at. Let's see. Landed at on June 22nd. Like I said, one of the longest missions, 14 days, a little before 1 o'clock Pacific time, out there at Edwards Air Force Base. And I was wondering if this had now I'm going to really impress you that I know this. Did it have the EDO on it? The extended orbiter. I don't think it did.
I don't think so, because they extended.
They wouldn't have room with all that cargo for the shuttle there.
They extended 2 days because to do the blanket repair. But no,
The
it wouldn't have.
The ADO means.
Okay, but the EDO is the extended duration orbit
Yeah,
pallet, where they
right, the pallet in the
carry
back.
the stuff to extend. And no, not with the size of the cargo they were hauling up. They wouldn't put a pallet in there. They put the pallets in there for the
I know why they didn't need it.
scientific missions. Yeah,
They didn't need it because they were attached to the space
Yes,
station. They
yeah.
could get extra
Yeah,
air and
yeah.
stuff like that there. Okay.
but not extra water. We always gave them water. Space station always wanted a drink.
Oh, okay. So
Well, the fuel cells produce water more than the orbiter needed, so we dumped water overboard through the whole flight.
Huh.
So whenever we went to space station, we gave them all the water that the orbiter produced.
did you dump it in the daylight when it would be raining, or in the evening, night when
Actually,
it
it doesn't rain
ice
it
cubes?
rain in space, but most astronauts said they would wait until the sun was just coming up over the wing, and they would dump the water out. It dumps out the left side just after the crew module, and it will come and it instantly turns to ice as soon as it gets out. And they said, you see all these gold sparklers going out through the thing with the morning sun shining on the ice.
Well, I've never seen a photo of that. But here we've got them back. Great mission, 117. Really one of the last hardware pieces, except the cupola of the space station, and which was taken up on 130, I believe.
Yep.
Kay Hires mission there.
Marty, did you have another
Go
question?
ahead, Marty.
Yeah, question from Phil Ramsey. How hot is the shuttle after landing from re-entry?
Extremely hot, especially the reinforced carbon-carbon. The tiles cool down relatively quickly, but the reinforced carbon-carbon does not. And when the orbiter's sitting on the runway, its nose is not very high off of the ground. And I always used to stand there and tell people they'd go up like they're going to touch it. So one, you're not allowed to touch it because you can contaminate, you can put oils and stuff off your skin on there. The other thing is it's so hot, your fingers will stick to it. It will actually burn you. I said, no, you don't touch the vehicle, especially the RCC. But the tiles cool down relatively quickly. But after we land, before we ever get around it, we send people in special self-contained suits to go out there and monitor to make sure none of the composites, the hazardous components, are leaking. So they walk around with special sensors and that, and long poles, and checking everything out. But it's sitting on the runway, getting exposed to airflow and that, and then we crank up huge propeller fans to help cool the vehicle down. But it's sitting on the ground for quite a while before somebody actually gets up close enough to touch it.
What do you mean quite a while? It lands an hour or
It's
after?
it's more than an hour. And the crew's still doing all their things inside, and then eventually say, okay, now we'll go get up the stairs up there to open the hatch and start getting the astronauts out. But, then people can start walking around it, but we're still basically in a hazardous operation. But yeah, I used to watch people that, I called them looky-loos. They weren't people that were there to work, but they'd want to go up and touch it. Tell them no.
No. All right. Great information from Terry White, the one and only. So glad that you found our museum and share this with us. You walking around the museum a little bit. Did you see any new exhibits yet?
I talked to some of your guests for a minute and that, and then
Oh, okay. Well, I want to show you the USIAC camera that was used to photograph the shuttle. Their
Okay.
field Hasselblad's there. We also have Nicole Stott's sleeping bag that
Okay.
she spent 90 days in on the space station. So
At KSC, they're building their new sleeping bags for station.
they are?
Yeah, I was in the shop the other day, and she was showing me that she's fabricating those right here to send up the station.
Oh, really?
Yeah.
To send them up to the station.
Yeah.
Okay.
Yeah.
Nikki's is a Russian sleeping bag
Okay.
because they had extra ones up there and they didn't want to send an American one up there.
Yeah, I was in the shop where Gene used to work.
Okay.
Talking to the
Well,
ladies
that's
that are still
interesting.
there.
All
So,
right. So some pieces and parts are still being made.
Yeah.
We'll have Terry back in November to talk about whatever he wants to talk about. But of course, we know that y'all love talking about the thermal protection system, the same type of stuff that's being used today in various spacecrafts. But nobody was really beating down your door or any shuttle engineer door to get knowledge off of you. They all want to do it on their own, don't they?
Nowadays, it seems like it. Yeah.
Yeah. Well, we've talked about that before.
Yeah. My former techs are frustrated with some of the new people that they're working with on the other programs now because they don't want to listen. They said, "Oh, we learned all these lessons years ago. What you're doing is not going to work." And then, yeah, I said, that's all you can do is tell them. So.
There you go. Marty, go ahead.
Yeah, question from Mitch Rothman. How many landings did you attend, Terry?
I forget. Only one California landing, though. I did go out on one California landing, but how many landings here, I don't recall. So, you know.
I think there's 78 here, if you attended them all.
78.
No, sometimes because I'm a hunter. Sometimes I was in a tree stand watching them come back. I was in a tree stand sometimes watching them launch. But yeah, so it depends on what it was. If I was assigned to runway ops, then I was out on the runway for the landing. And I think I've told you before, night landings were the most impressive thing because you'd be standing along the runway, trying to keep the mosquitoes off of you, but standing there in the dark and the orbiter's coming back, no lights. You know it's close because you heard the sonic booms as it came over Orlando and it's coming back. No light shining up at it because you didn't want to interfere with their vision. So it's coming and all of a sudden it just shows up right in front of you, you know, right, like 200 miles an hour coming by you as it's fixing to touch down on the runway.
Oh, that's something I'm envious of seeing for sure. That'd just be something amazing for sure. And yeah, they didn't want to have searchlights on it, bringing it in because the pilots had to land a doggone thing,
Yeah.
and they had to pay attention. And awesome, Terry. Thank you so much. We'll pick a date in November when you're not in a tree stand. You're going up to Ohio and get some venison steaks for me, right?
Hopefully, I don't know if it'll be Ohio, but hopefully I get some.
Thought you're going up to Ohio.
Well, may or may not. Got to wait and see how that is.
Okay. They have as many deer in Louisiana where your family is down there?
They do. I haven't gotten a Louisiana deer yet, but yeah, I've got a couple of hunts here in Florida to go to. So
Awesome. Did you get a ticket for the bear hunting?
no, I did not, but I got trail camera pictures from one place I hunt, and it only showed one buck on the trail camera and 3 different bears.
Huh.
And that's right over here between here and Orlando.
Is that right?
Yep.
If those of you don't know our news, bears have become a problem in some communities, and they're going to thin out the herd. And and that was a big political row that they had.
They're still fighting it. So,
yeah. So in fact, anti-bear hunters are trying to buy up all the tickets.
They are. Yep.
But have no opinion on that either way, as we do here at the American Space Museum. But you enjoy hunting, and God bless you and all you stand for is all I can say about Terry. So, all right. Thank you all for watching today.
One more
Marty's got
question.
another one there. Okay. Oh, here we go.
Yeah, Tom.
Tommy Usiak's going to open up a can of worms here.
Terry, if they do the dumb thing and move Discovery, do you expect them to ask for your assistance?
They are already asking for my opinion. They haven't asked for my assistance. But
The Smithsonian's asked for your opinion about it?
no, not the Smithsonian.
Oh, okay.
So far it's been the people who don't want it moved and it's some of the news media are asking my opinion, but all I can tell them is that will be a very expensive, because we have destroyed all the ground support equipment that would support the orbiter. So the last of it was used on Endeavour in California a few months ago to take it to the vertical position. And the guy I know that was the move director for that operation from here, he said before he even left, they were already cutting that stuff up for scrap. So they don't have that. And the other thing is, I don't know how they're going to move it, because they don't have a 747 still to move it. And if they move it by barge or by ship, I think they're going to have to disassemble parts of it, and we never disassembled parts of it here, so that will be a lot of work and a lot of replacing of the TPS, because if you take the tiles off to remove the wings or the vertical stabilizer and that, those tiles have got 39 flights on them, and you're not going to put them back on. You would have to get all new tiles, and I don't know what a tile costs in these days. The last time I used to get a bill for the tiles was in 1979 when Lockheed was supplying them to NASA, and the cheapest tile was $500 and the most expensive was $20,000 just for the tile. That did not include installing the tile. That was just for the plain basic tile.
$500 to $20,000 is what a tile.
And Columbia had almost 32,000 tiles on it.
Well, glad you asked that. There's a piece on Collect Space. Our partner Robert Perlman was on our board of directors a while. That's his website, Collect Space. A lot of chatter about postage stamps on there and collectible things. But there's Mark Warner, Virginia, is a setup with Mark Kelly, senator from New Mexico, that wants to not move it. And of course, it's two Texas senators that do want to move it, Ted Cruz and another guy. But just go out. We've got our buddy here, Eric Baker. Yes. Did you know Eric Baker had a letter printed in Aviation Week and Space Technology?
Yeah, I read it last time I was here.
About, yeah. And this is, so you support what Eric says, I would imagine. He says, I had the privilege of spending my entire engineering career at Kennedy Space Center on the Space Shuttle program as an electronics engineer. For 15 years, I was the OV-103 lead test project engineer, and I was proud to loan my orbiter to the astronaut flight crews. All right. OV-103 was the orbiter that made the most flights, including the most return-to-flight missions, and I was proud that it was selected as an orbiter to go to the Smithsonian. Johnson Space Center should be proud of its role in the shuttle program, but it was never home to the orbiters. The orbiters were assembled in California from segments constructed by companies across America. All space shuttle launches were from Kennedy Space Center, and he just didn't support it being the home, Johnson Space Center, having it there. And what the two senators on Virginia, Senator Warner, was emphasizing, they even had chopping up vegetables and stuff like that. It's like you can't chop this historic relic of space history apart, and they didn't. To me, it'd be like chopping up the name it, that you're looking at, tearing pages out of something, and so anyway.
Yeah, I learned a long time ago, shouldn't be in our vocabulary, but can do would be extremely expensive to take that orbiter apart, move it, and put it back together.
And it'd never be the same. It would never be the same again. I'm trying to think of some Civil War. Well, how about taking, whatever apart? I'm thinking.
You can't take new tiles and make them look old.
Yeah, exactly. It's the patina that we love, looking at Atlantis over and over. All right, so great question there. Anything else, Marty, to clean up the board?
Yeah, one more question from Nick Seidler. It seems to me that a lot of space-flown artifacts are small bits of reflective material that come from shuttle thermal blankets. Would you guys agree with that?
If that's the reflective material you're seeing, that is the internal blankets. Those are called TCS, Thermal Control System blankets. And they are silver and gold in color. Columbia, when it was built, was all gold, made from real gold. But yeah, so they're what protects the inside of the orbiter. Even if you take things off, like the orbiter maneuvering pod and the forward reactionary control system, you see these blankets down inside protecting things, because you know, only the crew module and that is pressurized in space. So even the payload bay is not. So all those things are underneath the white material that you see. There are thousands of TCS blankets protecting the vehicle. So yeah, a lot more of that is available.
Interesting. 4 tons of protective material on a 100-ton spaceship.
Yeah,
There.
as a
And
matter
all
of
you know.
matter of fact, this blanket, once it is flown, it is hazardous to breathe. So when we take them off, we had to suit up and use self-contained breathing to take these out, because they're tore up, and that batting is actually hazardous for your breathing. So you know, a flown blanket is not something that should be handled, because we didn't even handle them, you know, without protective clothing on.
Well, we do have some tile. We don't have much blanket on display. I probably ought to put a few things that we have laying around here on display that we've developed as we enhance things in our museum for you to come and visit us. But what a great visit by you, Terry White. Appreciate it a lot. He's become a fixture here, and I know you're supporting our dinner with NASA legends, and
Yes.
I expect to see you at Bob Seek November 5th, and then we're going to have a memorabilia show November 8th. But this weekend is auction weekend, and we will be talking about that tomorrow in some space history. Terry, thanks a lot. Marty,
Sure.
anything else over there to take care of?
No, we're caught up again.
All right.
Thanks for the good work, Marty.
No, we thank all of you for questions. We've done it before where you just showed up and started answering questions, and people like you, great listeners out there, want to understand more about the shuttle, even after the last one landed over 14 years ago, my friend, on there. So
And thank you for all of your questions. It really makes the show better when we know what you're interested in.
and it validates what we're doing, Terry.
Yes.
Absolutely. We don't want to talk to dead air. And why there's not 1,000 people watching with you on, I don't know, because that's what our program is about, is space workers like this gentleman that, I mean, just every time I learn so much, and we could go off on another tangent with that,
Yes.
you know, and often we do. So, well, thank you everybody for a wonderful Stay Curious. Okay, go outside, get you some starshine. There's a comet to be seen up there. Just Google whatever your applications you have. It'll show you where it's at up there. But get out of the house, away from the TV a little bit, and get some fresh air. Beautiful month of October, one of my favorites. And we've actually gotten cool down here where the windows are open in my house. So until tomorrow, when we're going to look at a TGI Friday and talk about our auction that we want you to participate in. Until then, I'm Mark Marquette, saying we can't wait to see you in our museum to bridge the space between us.